Not right now, though.
So if it's not crossed like this when there's number two.
Then you did something wrong. Yeah.
I'm pretty sure I'm
Let me pull this up real quick. I don't think I have it up here yet. Oh, I think this might be, is this your, oh, this is your class. This is great news. Yay. Okay, so the question was asked, can we just get started on number one? And no, that is not a stupid question. What we want to do is make sure coming into Thursday that we're good to go on all different types of problems. So if you're interested, here's problem one, and we can hit anything else on pages one or two that you want, and then we'll head over to the substitution. If you want to just tune me out today, that's fine. Like you're welcome just to do that. And then maybe if you go back, watch the recording or have a question later on, then that would work. So, what are we doing in problems 1 through 4? Yeah, we're just graphing lines and seeing where they cross. So I will tell you a couple of things if you're interested. Number one, on the front page and the second page, there are no parallel lines and there are no overlapping lines. So there are none of the weird ones where you write like no solution or any of that. These are all just straight up old school lines that cross at a point. And if your point is not like a nice one, you screwed up. If your point falls off the graph, you screwed up. Okay. So these are all nice and right in the grid somewhere. So let's start with the first equation on number 1. So where are we going to begin our graphing journey on the first one? The one with the red dot next to it there. We're going to start by going up 2, and then what's the slope going to be like? Perfect. Down 2, and then as always, you're going to have a choice to make. Do I go right or left? And the answer to that question can only be found in just using common sense. If you want the line to have a negative slope, make it negative. And we can go up 2 and left 3 as well. Okay. And then you grab your ruler and you make a line through the points like such. Sorry, it's not perfect, but it'll do. And so that is number 1, like the first graph. Okay. For the second graph, we're going to, I'll use purple for this one. Where do we start our graphing journey? Down 2, put a dot. And then what's the slope? Yeah, it's a 2-to-1 ratio of rise and run. And so, you got to go down 2 and something. And to make it negative, you got to turn right 1. And then since that's nowhere near enough points, you want to do a bunch more points. As many, I've always said like as many points as you can. So, and then if I go up 2 and left 1 again, be right about here. And then make sure, we don't break with expectations just because of what we're doing. We're still graphing lines. So we're still going to make them long. They're going to go out the grid. They're going to have arrows on them. Like none of that changes just because we're not in unit 3. And then the final step is to you don't have to circle it. I always do, but if you circle it and then you can name it. And what is the name of that point? Good. So the answer to this problem is written in green. So everything that you see in purple and red is just the work. The green is the actual solution that we want to write down. Is there anything else on that first page that you wanted to talk about? Katie, you want to hop over to the substitution right now, or do you want to wait? Yeah. Are we heading over? Oh, okay. So we're going up to number 9, right? Okay. So anyone who's interested and wants to come along, you're welcome to. This is page 3. So this is where we changed it to a new system now, a new method called substitution. I sometimes call this the box method, you'll remember. So this is the one where we want to look at the 4 variables, and we want to pick the one that would be the easiest to get by itself. And we would unanimously agree that the top X is the friendliest because it doesn't have a negative or a number or anything. So if I take that top equation and I solve it for X, what would it say? X equals, good. And I've seen an alarming number of times today where people want me to go over a problem because they got a fraction. And the reason is because they forget to change the sign of something when they move it across the equal sign. So That's something I'm not going to be there to help you with. I doubt you're going to struggle with that, but just be hyper vigilant about if it jumps an equal sign, it changes. That's like the law of the land. And then you know how I roll. I'm going to box this up. And what am I going to do with that box? In place of which letter? X, you said. Okay, sorry, I couldn't quite hear you. So we have 7 times where X used to be minus Y equals 3. And then in that void where X used to be, we're going to put the contents of the red box, which are negative 4Y and minus 12. Is that ringing some bells? And then from here, we just want everything to go like good, come on, basic skills, right? So when we distribute, what do we get there? Careful. Nice, negative 28Y. And then how about this one right here? It's definitely negative. Nice. So negative or minus whatever, 84 minus Y. And then what's the next thing we would always do in a case like this? Heck yeah. Combine those like terms. The ones specifically first on the same side of the equals, the negative 28Y and the minus 1 more Y make negative 29Y. And since it's January 21st and not like September 4th or something, I'm going to go ahead and also, while I'm here, add 84 to both sides, giving me 87. We didn't used to skip steps like that, but we're not rookies anymore. And when we divide both sides of this little eensy beensy equation by negative 29, we get our answer y equals negative 3. Now, what do we do with that partial answer? Plug it back up in that box, right? So you'll see when you look at my answer key on Canvas, if you'd ever do, which you should, you'll see that I constantly on substitution am drawing this arrow. That's just my way of reminding you that that's where I'm putting that number to get my second answer, okay? So when I put that in there, I don't have to do very hard math at all. I just have to change the y that's in the box into negative 3. And then you just do the little kitty math. What's negative 4 times negative 3? Positive 12. And what's 12 minus 12? So we can now say also that x equals 0. So the final step in the process is to write the answer. And the answer should be a collected ordered pairs where we say, okay, x is 0, y is negative 3. That's what every final answer should look like, is a pair. That ringing some bells? Right on. So before we leave, I want to make sure on the recording that I get at least one elimination. I'm going to pause the recording unless you have more questions right now. Then I'll just keep rolling with you. But I'll just, every time you have a question, I'll unpause, go over it, pause, so on and so forth. Yep. Is this a go over it or should I pause my recording? Okay, I'll just pause it then. Number 5 is, I mean, every question you have is excellent because you're asking it. And I salute you when you're willing to ask for help. But this is an excellent question specifically because what changes when we get to page 2? You actually have to do something other than graph a stupid line. And I don't mean that to be rude. Like if you struggle with graphing lines, no offense, but like that's pretty light work. When you have to prepare them, that's not light work. Like now it's legit. Like I better know what I'm doing. So what's our overall goal for like, let's say this one? What are we trying to do?
Get the y.
I mean, they're the 4 words that are really going to get you through this are get, y, by, itself. Like that's become sort of our battle cry. Like this isn't a standard form kind of thing. This is y equals mx plus p. When given the choice to graph in a case like this, most people say, I'm going to put it in y equals mx plus p. It's the safest. It's a nice, accurate way to graph. Okay. So that little 4-word saying is going to get us through this page. Now, ironically, there's a problem in here that doesn't have a y. So you're like, well, how am I supposed to do that? Well, we've been down this road before, but let's talk about the top one first. So, Colton, how would you go about getting y by itself?
Yeah, well,
That's exactly what I would do. I would just leave the negative 4y, just kicking it on the left. And then what would I get on the right?
well,
Yeah, that makes my heart happy that you're very comfortable and good at that. That's huge. That is so hugely atop my list of to-dos for you guys in this ninth grade year, is can I get you to do that? What's the next thing we do? Divide -4. Listen, here's the deal. I would tell you that I don't need to see you subtracting 5x from both sides, but I'm going to tell you that you should show this step. And I'm not going to tell you that because like I'm going to make it worth points or I'm trying to control your behaviors. It will help you to not screw up this next step if you show the division. Mark my words. So that one's not for your teacher. That one's for you. When you divide, you should show it. It exposes the fractions. And so, Colton, we're ready for a final answer. We get y equals what? So 5/4 times x. No, no. First off, it's a negative, so I'm going to put minus, but 8 divided by 4 is not 4. If Marvin has 8 tacos and he and his 3 friends, 4 people are going to split the tacos, how many tacos can they each have? 2. I think I'm maybe just sort of partially decided that it might be taco night in the Ahern house tonight. So there you go, tacos. I would invite you all over, but not going to. So
We have team dinner.
get your own taco. Oh, good. So hey, Colton, how do you feel about that?
Yeah.
Okay, so that one I'm going to put a box around that. If I were a student, I would put a box around that just to show my teacher, like, this is really important. I want you to look at this. This is what I'm going to graph. That box, I'm a big fan of boxes. They're like a statement of, hey, looky here kind of thing. So let's graph that, eh? Where do we start the graphing journey? Okay. And where do we go from there? Don't say over 4.
Right.
Yeah, this conversation's been going so well. Don't make me cuss at you, especially because I'm recording, for goodness sake. So up 5, 1, 2, 3, 4, 5, and then right 1, 2, 3, 4. And that's all the room that we have for that particular graph. So you're going to connect those dots with a line, right? Well, I'm just going to do this. I'm just going to cheat it a little bit. It's so pretty. It's so pretty, Claire. So, Colton, you good so far? Sweet action. Now, this is the one I'm going to get a lot of questions about. It could be people that are listening and still don't get it. It could be people that aren't listening and then ask later. But here's the deal. I get so many questions about these. And every year I say to myself, this is going to be the year I convince these kids that these are the easy ones. It never works. What kind of line is that? You know that, don't you? So you figured it out. You got the memo. It's vertical. There's so little that we have to do here. This isn't like dividing and y equals mx plus b. How do you get x by itself? And if you add the 4 to both sides, what do you get? You get x equals +4. And I can put a box around that too. I mean, how people get stuck on those, I will retire not understanding. But man, to me, that's just like, thank you for the free points there, math gods. I appreciate that. And so you said it that it's a vertical line, right? So I'm going to go right to 4 on the x-axis and maybe make a little mark. And then I'm going to set my ruler down and I'm going to make a nice vertical line straight down through 4 to the right. You still with me?
Yep.
And now the only thing I have left to do is to identify the crosser. It's right there. What's his name, Colton? Just like that. So we're going to, not 4/3, it's not a fraction, right? So 4, 3. Just no other words, just 4, 3. That's how we name a point, just like that. And the rest of that page is honestly just more of the same. Like, you do whatever you got to do to either get y by itself or get x by itself, but usually it's going to be y. You guys have other questions? Sure. You don't have to preface every question by telling me that it's going to be a dumb one, because A, it's probably not. Okay. So this page is where the elimination starts. And there's a lot of There's a lot of stuff going on here. There's very few level one problems, by the way. You'll notice that I don't think you even encounter a level one until you get to the bottom of the page. Do you guys know what I mean when I say level one? Easy ones that are already ready to eliminate, right? So don't expect a lot of that kind of free stuff. So in problem number 17, for example, we want to pick a variable to eliminate. Well, first off, we want to make sure everything is in line. And you'll notice that the x's are lined up, the y's are lined up, the equals are lined up, and the constants are lined up. So that should be objective numero uno, is get everyone where they should be. So having said that, who's going to be the easiest variable to kill? There is no real right answer to this question. Yeah, I would probably pick the x's. Just what can we turn a 3x and a negative 5x both into? Yeah, 15. And it's nice we don't have to tinker with the signs. Would the y's have been super hard? No. What do you turn a 10 and a 3 into? 30. So it's like, whatever. We're not scared. So we're going to go with x's just because I think it makes sense. So we're going to multiply the top equation by 5 and the bottom equation by 3. And I found myself doing a lot of multiplication off to the right just because those dumb problem numbers that the computer prints get in the way. So you can do distribution from either side. It doesn't matter. Now I'm going to rewrite the system. So what would the top equation now be?
15
Yep.
plus 50
Plus 50y equals, nice, in the bottom. Yep. Minus 9y equals. Perfect. There you go. And now I draw the line underneath it. As I said before, the line is like a beacon that I use to mark where addition is about to take place. So it helps me to stay organized. So my x's are going to eliminate. When I add downwards, the x's go poof, poof by. How many y's are left when we add? 41, which makes us feel a little panicky, like, holy smokes, man, 41y, that's like, whoa. But usually what I found throughout these problems is if the number on the left was a little bit concerning, the number on the right should bail us out. And sure enough, what's 5 plus 36? 5 plus 36 is just 41. And that's nice because 41y makes us think we did something wrong. But then you realize, oh, good, I just get to divide 41 by 41. And that's actually really good news. So what does y equal? Sweet action. And as I've said umpteen number of times, the only drawback really to elimination is that unlike substitution, I don't have that handy dandy little beautiful box to put the 1 back into. But whatever. Like I said, we're not scared. We're tough. So I would personally use this equation with the little green arrow up here pointing to it. It just feels to me like the nicest one. So what I'm going to do is I'm going to take that equation, and where it used to say y, I'm going to put in a negative or a positive 1. So what's it going to say? So 3x plus, and then 10 times 1 is just, yes, 10 equals 1. And then we just solve. Little kitty algebra, what do we do from here? Subtract the 10, which gives us negative 9. And then from here, divide everything by 3, giving us x equals, leading us then to our final answer. And the answers are kind of already on the board, but your teacher has asked, I think, multiple times that we write our answers as ordered pairs. So rather than say, hey, x is this and y is this, I speak for almost all math teachers when I say, we want that cleaned up, man. We want the answer to be listed as the point -3, 1. That's how they should be. Okay. So we've covered graphing. We've covered graphing when you have to get y by itself. We've covered substitution. We've covered elimination. And we still have like 5 minutes. So there's more time if you have more, but that's a good start. Sure. Do you have more questions? No? You're what? Thinking about how awesome math is? Thinking about how math is the greatest subject in the school? That's it.